nucleus. Okay, so it is basically denoted by X, a Z, A. Okay, so this kind of symbol we basically use to represent nucleus. Okay, where Z is called atomic number. Z is called what? Atomic number. Okay, or we can say that this represent number of protons. Number of protons present inside that nucleus. Okay, and A is basically called mass number, right? A is basically called mass number, or also that A is nothing but, this is also called number of nucleons. Number of nucleons present inside that nucleus. Okay, so this is a symbol, right? So number of nucleons present inside that nucleus, number of nucleons is nothing but number of neutron plus number of proton, and number of proton is nothing but Z. So this A is nothing but number of neutron plus number of proton. Okay, it means N will be nothing but A minus Z. Okay, and N is called number of neutrons present inside nucleus. So this is a symbol, right? You have a proton number, Z, A is your mass number, and N is your number of neutrons present inside nucleus. Okay, so in generally number of number of electrons in an atom, कितना number of electrons होते हैं generally?
Number of protons की.
Exactly. So number of electrons in an atom, that will be equals to Z, right? So that actually makes that atom neutral, because you have a nucleus. Inside nucleus you have an atom. In an atom you have a nucleus, and inside nucleus you have a Z number of proton, and which is actually positively charged, and each proton is having same amount of charge as electron, but that charge is actually positive in sign. So I can say for each proton is having how much charge? Plus E charge. But in an atom you have electron also, and electron is actually negatively charged. So if I combine all charges, you have a proton that is positively charged, you have a neutron that is neutral, and electron. So if I combine all charge all together, the atom will be actually what? It will be neutral, right? Did you get what I'm trying to say? Is it clear? हाँ ना बोल दिया करो.
Yes.
Okay. Yes. So we know that mass of electron is how much? कितना होते हैं? In terms of MeV, this is nothing but 0.5 on mega electron volt per c square. So Me is the mass of electron that is nothing but 0.5 on MeV per c square. Mass of a proton MP, that is how much? In terms of MeV, it will be 938.28 mega electron volt per c square. And mass of a neutron, that is how much? That is 939.557 mega electron volt per c square. Okay, so what I can say, that mass of a proton is almost same as mass of a neutron, but mass of a proton is much greater than mass of a electron. Okay, but please keep in mind there is slight difference of mass of proton and neutron. जो neutron का mass होता है, that will be slightly larger as compared to mass of a proton. Why I am saying, this time TIFR asked a question. TIFR asked question this year, and most of the students made a mistake. They have taken the mass of neutron is same as mass of proton, and they took that correct option, wrong option actually. So you have to keep in mind, mass of a neutron is almost same as mass of proton, but it is not exactly equal. There is slight, actually neutron is slightly heavier as compared to proton. Okay, you have to keep in mind. Okay, so basically in terms of अगर relation लिखे, mass of a proton कितना होता है? On 836 time mass of a electron. You know this, right? You people know this, right? Mass of a proton is on 836 time mass of an electron. So this is just a introductory part. Okay. Is this clear? So nothing is there? Yes. Now we'll discuss that important experiment, and that is very famous, that give that structure of atom, and that experiment is known as Rutherford scattering experiment. Okay. And this experiment basically came in the year of 1910. Okay. So in that experiment, you have a source of alpha emitter, and Rutherford basically took that source, a radium, atomic number 88, mass number 226. He has used this radioactive source, or basically this source is basically alpha emitter. You know what is alpha, right? What is alpha? Alpha is nothing but helium, doubly ionized helium. It means alpha particle contain 2 proton, 2 neutron, but there is no electron, right? So he has used this radioactive source or alpha emitter, and he kept this source in a lead box, inside lead box. Okay, so this source emitting alpha particle, and there is a slight hole in a box, so this alpha particle is actually emerging from box, and he has used a very thin gold foil.
The alpha particle here means helium-2 plus.
Yes, alpha particle means helium-2 plus. You know what is helium, right? Helium means He24. What does it mean? It means helium atom has
2 protons.
proton, 2 neutron. This is what? This is your mass number, right?
Yes, sir.
Mass number में क्या क्या है आपका? Neutron plus proton, right?
Yes, sir.
So neutron plus Z, that is your 4. And you have Z is how much? 2. So obviously number of neutron will be how much? 4 minus 2, that will be 2. So 2 neutron is there, 2 proton is there. और हमको पता है न्यूट्रल एटम में क्या होता है, नंबर ऑफ प्रोटॉन इक्वल्स टू नंबर ऑफ इलेक्ट्रॉन होते हैं. इट मींस इट हैज 2 इलेक्ट्रॉन एज वेल. नाउ इफ यू आयोनाइज 2 प्लस मतलब क्या है, यू हैव रिमूव 2 इलेक्ट्रॉन फ्रॉम हीलियम. तो कुछ इलेक्ट्रॉन बचा रहेंगे वहां पर. इज देयर एनी इलेक्ट्रॉन आफ्टर टेकिंग, आफ्टर रिमूविंग 2 इलेक्ट्रॉन्स? कोई
No, sir. No, sir. No, sir.
So you have a source of alpha emitter, that is radium. It is emitting alpha particle, and you place a very thin target, and this is basically what he has used this target, that is gold foil. But this is very thin. The thickness of this gold foil he has taken, and that is very thin, 4 into 10 to the power minus 5 centimeter. Okay, and of course, this target is surrounded by okay, fluorescent screen. So this alpha particle, okay, there is a hole here. This alpha particle emitting from radium, and it is basically striking this target. And what he observed? He observed that most of the alpha particle, after striking this gold foil, is what is happening? Most of the alpha particle, after striking that gold foil, their path is actually undeviated. What he is observed, whatever alpha particle is striking this gold foil, most of the particle after passing through this gold foil, the path is actually undeviated. Okay, so you can mention that observation. You can write that observation. Observations. Observation on number 1. Most of the alpha particle passes through the gold foil without any deviation in path. Okay, most of the alpha particle passes through the gold foil without any deviation in path, है ना. जैसे straight line में जा रहे थे, after striking this gold foil, it is passing through this gold foil without changing any path. Okay, this is the observation, first observation. What is next observation? Second observation is only few alpha particle are scattered. Only few alpha particles are scattered at small angle. So suppose you have a gold nucleus. You have a gold nucleus. Okay, so this is the structure of gold. So this is the incident alpha particle. इसको बड़ा कर लो. So what he has seen that most of the alpha particle is actually undeviated. Okay, इतना भी नहीं होगा. But few alpha particle is actually scattered. Few alpha particle is scattered at small angle. At small angle theta. Okay, that was the second observation. Third observation, only very few alpha particle. Third observation, only very few alpha particle particles are scattered at large angle. Okay. Only very few alpha particle are scattered at large angle. And observation number 4, only on out of 20,000, only on out of 20,000 incident alpha particle is backscattered. Backscattered means what? It is going like this, and after scattering, it is coming in opposite direction. So there are he has four observation. First, most of the incident alpha particle after crossing that gold foil, their path was actually undeviated. Second, only few alpha particles scattered at small angle. Third observation, only very few alpha particles scattered at large angle. And fourth observation was only on, suppose you have sent 20,000 alpha particle, out of 20,000, only one alpha particle is actually backscattered. Okay, backscattered means the incident alpha particle direction is this. After scattering, it is coming in opposite direction. That's why it is called backscatter. So what is the conclusion? You can mention now conclusion. What is the conclusion? What is the conclusion? So first conclusion. So from first observation, what I can say? Only most of the alpha particle is undeviated. What does it means? What is the conclusion of that? It means,
Sir,
yes.
sir, most of the part of atom is empty.
Exactly. So first conclusion from first observation is that most of the space inside atom is actually empty. Most of the space inside atom is actually empty. Now from second and third observation, what will be the conclusion?
There is small mass or charge concentrated at the center.
So we know that exactly. We know that alpha particle is having positive charge, right? Alpha particle is having positive charge. And what is happening? You have a nucleus, right?
Yes, sir.
So you have an alpha particle. It is incident and it has positive charge. So scattering at some angle. When there will be scattering? If there is some force, right? So since alpha particle is positively charged, so of course that atom should have some positive charge, right? So he said that inside nucleus, there is some positive charge. And this positive charge is actually, because of this positive charge, there is a Coulomb repulsion between alpha particle. I mean, this positive charge actually repulsing this alpha particle, right? Because alpha particle is having positive charge. So of course there is some positive charge that is actually repulsing this alpha particle, and because of this there is a scattering. Okay, so from second and third observation, what I can say, that nucleus is having what? Positive charge. Okay, there is some positive charge. Now last observation, there is a backscattering. So from last observation, what will be the conclusion?
Size of nucleus is very small.
Yeah, size, that you can say that only on out of 20,000. So two things we can say, that only on out of 20,000 is backscattered. So he conclude that most of the mass of that atom is concentrated at the center. You can mention from last observation, he conclude that most of the mass of the atom is concentrated at the center, and he has given the name of this center is called nucleus. And of course, someone mentioned that size of nucleus is small. We can conclude also that because only on out of 20,000 is backscattered. So it means size of nucleus is small. That also he conclude. So conclusion is very simple. First of all, most of the part is empty inside atom. Second, there is some positive charge concentrated at the center. Okay, and due to the Coulomb repulsion, there is a scattering. And from last observation, we conclude that most of the mass of that nucleus is most of the mass of that atom is concentrated at the center, and he has given the name of this center as called nucleus. Okay, and of course, he said that size of the nucleus is small because only one alpha particle is scattering out of 20,000. Out of 20,000 means you are sending 20,000 alpha particle, and after interaction, there is only one alpha particle is actually backscattered. Okay. And also he predict that size of nucleus as well. He predict that size of nucleus by calculating distance of closest approach. We'll calculate that also at the end of this discussion. Okay. So he predict that size of nucleus. Also he said that you have a nucleus. He said there is a mass, whole mass of that atom is concentrated at the center, and he has given that mass of he has given that name of that center as called nucleus. And he said that electron is actually revolving around this nucleus. So what he has discovered, he discovered that nucleus. He said that mass, that location at which mass is concentrated, that point is called nucleus. And also he said that electron is actually revolving around this nucleus. Okay.
Sir, so how he predicted that electron is revolving around the nucleus?
He predicted. I mean, it's a he predict that. I mean, so how he predict that that I can't say now right now, but he predict. He said there is a there is electron that is revolving around this nucleus, and due to that Coulomb Coulomb attraction, he said that electron is having negatively charged, so there is a Coulomb attraction. There is a Coulomb attraction, and there is a Coulomb attraction, and you have a centrifugal force, right? So in a charged particle or any particle revolve, or when there is a revolve, when a particle is making periodic motion or orbital motion, there will be a force, and that will act away from the orbit, right? And that force is called centrifugal force. So when that electron is revolving around nucleus, that centrifugal force actually act outwards. And you have an electron. Electron is negatively charged, so there is a Coulomb attraction between electron and nucleus, because nucleus is having positive charge. So he said that the orbit of this electron will be stable because the centrifugal force is balancing with Coulomb attraction. So these two forces are balancing. As a result, that electron orbit is stable.
Sir,
Hmm.
but from this experiment, we cannot conclude, or we cannot say that electron is revolving.
Exactly. That was his prediction,
Okay, sir.
he predict.
Maybe it could be
Hello, sir.
Yes.
due to
Sir,
small
according
and large deflection.
Yes. Someone was asking.
There
sir,
is
I'm
small
saying that according
because of that electron also playing attractive force on that positive charge, and a large deflection because of the they are matlab, wholly repulsive by the positive charge of the nucleus. Maybe it could be.
Actually, I can't hear properly what you are saying. Can you please repeat it one more?
Sir, I am saying that maybe the postulator 2 and 3, which are saying that there is a small angle scattering and also a large angle scattering. The small angle scattering could be due to that attraction and repulsion of the positive and negative charge.
No.
The small angle
No,
scattering.
small angle and large angle. You see, when it will be small angle. So suppose I am giving two incident alpha particle. Suppose this is on incident alpha particle, another will be this, and you have a positive charge here. So जो आपका अल्फा पार्टिकल बहुत क्लोज होंगे न्यूक्लियस का, उसका स्कैटरिंग एंगल ज्यादा होंगे, और जो थोड़ा दूर में होंगे उसका स्कैटरिंग एंगल थोड़ा कम होंगे, और जो बहुत दूर होंगे वो अनडिवेटेड होंगे. आर यू एग्री विथ दिस? जो बहुत करीब होंगे उसमें ज्यादा फोर्स लगेंगे, ऑब्वियसली स्कैटरिंग एंगल ज्यादा होंगे. जो थोड़ा दूर में होंगे उसमें फोर्स थोड़ा कम लगेंगे, स्कैटरिंग होंगे बट थोड़ा कम एंगल में होंगे, और जो बहुत दूर पर होंगे उसका कोई डेविएशन नहीं रहेंगे.
Okay, sir.
हाँ, someone was asking something else.
हेलो.
yes.
हाँ सर, आपने एक बात बोली कि रदरफोर्ड ने ये कहा था कि जो इलेक्ट्रॉन घूम रहा है वो एक स्टेबल ऑर्बिटल पे है सर. बट सर जो रदरफोर्ड का ड्रॉबैक था वो तो सर ये समझा ही नहीं पाया था ना कि जो इलेक्ट्रॉन है वो ऑर्बिटल वो मोशन कर रहा है,
हाँ,
क्योंकि वो तो सर बोहर ने समझा.
एग्जैक्टली, बोर ने भी नहीं समझाया, बोर ने प्रेडिक्ट किया था. देखो बात ये है.
सर बोहर ने कहा था ना.
हाँ, नहीं, आई एम टाइम, लेट मी गिव टाइम.
Yes, sir.
So according
Yes, sir.
to Rutherford said that electron is revolving around orbit, and there is a two force. One is called Coulomb attraction, that is acting towards the center of the nucleus, and centrifugal force that is acting away from that nucleus. So these two forces are actually balancing. As a result, that orbit is stable. But major drawback was that when charge particle is revolving, it is actually accelerating, right? When charge
Yes,
particle
sir.
is
Yes,
revolving,
sir.
it is actually accelerating. Okay. So when a charge particle accelerate, what will happen? It will emit radiation.
Sir, it will emit, हाँ sir,
It will
it's
emit radiation.
electromagnetic
When a
waves.
charge particle accelerate, it will emit radiation. So it will continuously, when an electron is revolving, it will continuously lose its energy. So when it will lose its energy, obviously it will change its orbit. इसका ऑर्बिट को चेंज करते रहेंगे.
Yes, sir.
और एक टाइम में क्या हो जाएंगे?
Yes, sir.
न्यूक्लियस में कोलैप्स हो जाएंगे.
Equalize कर जाएगा. Yes, sir.
Okay. So he was not, he cannot, he said it is stable, but it is not true, because when a charge particle is revolving, it will emit radiation. As a result, it will continuously lose its energy and it will continuously change its orbit, and once it will collapse with nucleus. So that was drawback. Now you are saying that rather बोर्स ने उसको ये किया था, प्रूव किया था. बोहर ने भी प्रूव नहीं किया था. बोहर का जो सेमी क्लासिकल मॉडल है, बोहर का जो स्ट्रॉन्गेस्ट एजम्पशन था, बोहर का जो स्ट्रॉन्गेस्ट एजम्पशन यही था कि इलेक्ट्रॉन जो है, इलेक्ट्रॉनिक ऑर्बिट जो है स्टेबल है. बट व्हाई इट इज स्टेबल, ही नेवर टेल व्हाई इट इज स्टेबल.
Yes, sir.
Later Schrodinger wave equation proved. Schrodinger wave equation in quantum mechanics, you will learn this. Schrodinger wave equation proved that electron orbit is actually stable. पर बोर ने भी आपका डिस्क्राइब नहीं किया था. उसका स्ट्रॉन्ग assumption जो था that electronic orbit is stable. ठीक है. Schrodinger-Wave equation prove that electronic orbit is stable, but ना तो रदरफोर्ड डिस्क्राइब कर पाया, ना तो बोर डिस्क्राइब कर पाया. ठीक है. इज दिस क्लियर?
ओके सर.
ओके. सो हाउ डू यू लर्न?
मतलब इन लोगों ने बस प्रेडिक्ट किया था ये
हाँ,
चीज।
वही मैं बोल रहा हूँ ना, जैसे बोर्ड ने प्रेडिक्ट किया था, बोर्ड ने क्यों एज्यूम किया था, बोर्ड व्हाट बोर्ड एक्चुअली डिस्क्राइब, कैन यू प्लीज टेल मी एनीवन?
यस सर. Sir, angular momentum is equals to the integer multiple of h upon 2 pi.
Yes. Actually, Bohr used semi-classical theory. He linked that classical result with quantum result, and that's why it is called semi-classical theory. And Bohr का जो main motivation था to describe that line spectra, जो atomic spectra मिलते हैं ना, उसको describe करने
Yes sir. Yes sir.
theory था. But he has
Yes,
that
sir.
assumption. Okay, he never describe how that orbit is stable.
Okay sir.
तो सर ये जो न्यूक्लियस के अराउंड की जो रेस जाएंगी वो मतलब वही सब डिवेट होंगी, बाकी जो ऊपर से जो रेस जाएंगी वो पूरी
हाँ देखो, जो
पार हो
आपका
जाएंगी.
जो आपका एटम है, एटम के अंदर क्या होता है, एक न्यूक्लियस होता है. न्यूक्लियस का साइज कितना होता है? न्यूक्लियस का साइज कितना होता है?
वेरी स्मॉल.
ऑफ द ऑर्डर
Approx 1 Fermi
ऑन फर्मी
of Fermi.
एटम का साइज
10⁻15
10 के -10 मीटर, राइट? तो
Yes.
न्यूक्लियस और एटम के बीच में कितना गैप है? 10⁵ ऑर्डर में गैप है, 10⁵ मीटर. इफ यू कैलकुलेट दैट साइज ऑफ radius of atom divided by radius of nucleus, you will get that order, that will be 10⁵ meter. So in between nucleus and electronic orbit, you have that much of gap. So and that gap is actually completely empty, होगा. अब जो अल्फा पार्टिकल आ रहा है काफी हाई काइनेटिक एनर्जी लेके आ रहा है ना? तो जो अल्फा पार्टिकल न्यूक्लियस का बहुत करीब होंगे वही अपना पाथ को डेविएट करेंगे, और जो थोड़ा दूर में रहेंगे वो कभी डेविएट नहीं करेंगे, क्योंकि उसके पास इतना एनफ काइनेटिक एनर्जी है कि थोड़ा बहुत जो कूलम रिपल्सन होगा उसको अपोज करके अपना पथ में ही चलेगा. वो जो थोड़ा मतलब बहुत करीब आएंगे उसी को रिपल्स कर पाएंगे, क्योंकि उसके पास एक अपना पावर भी तो है, enough kinetic energy, that and that kinetic energy is of the order of mega electron volt. Okay.
सर मतलब वो पार्टिकल न्यूक्लियस के अराउंड डिवेट होंगे, बाकी इलेक्ट्रॉन से मतलब नहीं है.
है ना, इलेक्ट्रॉन से मतलब नहीं है, इलेक्ट्रॉन से कुछ मतलब नहीं है उसका. ठीक है.
ठीक.
Now that main thing that in that lecture, that is we are going to discuss on parameter, on property is called impact parameter. On property is called impact parameter. What is impact parameter? And it is basically denoted by P. Okay. So suppose you have a nucleus. Suppose you have a nucleus, and this is the center, and suppose this is the electronic orbit. Okay. And suppose a alpha particle is incident. This is the alpha particle, and kinetic energy of alpha particle is k alpha. Okay. So impact parameter is defined as, you can mention, then I'll tell you. It is defined as minimum distance. It is defined as minimum distance at which alpha particle, or better you can write incident alpha particle. It is the minimum distance at which alpha particle or incident alpha particle would approach the nucleus if there were no force between them. It is the minimum distance in which incident alpha particle would approach the nucleus if there were no force between them. Between them का मतलब क्या है? Between nucleus and alpha particle. तो सपोज मान लो ये आपका अल्फा पार्टिकल है, ये इंसिडेंट हो रहा है ना? अगर कोई फोर्स ना काम करे दोनों के बीच में, तो कैसे चलेंगे? इट विल बी गोइंग लाइक स्ट्रेट लाइन, पूरा स्ट्रेट लाइन होंगे, है ना? It will be going in a straight line path if there are no force between them. Now what will be the minimum distance? I think this will be the minimum distance, and this is called impact parameter.
सर मतलब कि न्यूक्लियस और अल्फा पार्टिकल के बीच में जब फोर्स ना लग रहा हो तब वो
Exactly.
डिस्टेंस भी होता है।
Exactly.
ओके सर।
It is the minimum distance at which alpha particle would approach the nucleus if there were no force between them. If there are no force between them means whatever alpha particle is incident, it will be going in a straight line, right? So minimum distance will be how much? This will be the minimum distance. Okay. And another property I have to, or another parameter I have to write, and that is called scattering angle. Scattering angle. And that is basically denoted by theta. Okay. You can write, then I'll explain. The scattering angle is defined as angle between direction of incident alpha particle. Angle between direction of incident alpha particle and
Can you repeat it, sir?
exactly, I'll repeat. Yeah. The scattering angle is defined as the direction of incident alpha particle. Defined as the angle between the direction of incident alpha particle and asymptotic line of departed alpha particle. The angle between the direction of incident alpha particle and asymptotic line of departed alpha particle. So can I explain now?
Departed alpha particle.
Departed alpha particle. Now let me explain, then it will be clear. So suppose you have a nucleus, and let us assume this is your electronic orbit. Okay. So now suppose a alpha particle having kinetic energy K alpha is incident. So when it is incident, what will happen? Tell me. When it will come, so direction of alpha particle, how will define? So this will be the direction of alpha particle. This will be the direction of alpha particle. Or better, I'll write small. So this is the direction of alpha particle. Is there any doubt? This alpha particle is approaching that nucleus. So direction of incident alpha particle will be what? This is the direction. Am I correct? हाँ ना बोल दिया करो.
Sir.
Yes, sir.
Okay. Now tell me, when it will come to very close to nucleus, what will happen?
It is scattered.
Exactly. It will be coming, then it will be scattered like this, right? There will be some kind of curve. So this will be the, okay, थोड़ा सा कर्व जैसा होता है इस तरह की. So this is the direction of incident alpha particle, and departed alpha particle मतलब क्या है? After scattering किधर जा रहा है? ये आपका इंसिडेंट इधर नहीं जा रहा है, अभी आपका अल्फा पार्टिकल किधर जा रहा है? डिपार्टेड मतलब स्कैटरिंग होने के बाद किधर जा रहा है. और ये थोड़ा सा आपका कर्व जैसा होता है, और कर्व से एक आपका क्या करते हैं हम, एसिम्प्टोटिक लाइन बनाते हैं, है ना। तो जो डिपार्टेड अल्फा पार्टिकल का जो एसिम्प्टोटिक लाइन है, उस लाइन के साथ जो इंसिडेंट अल्फा पार्टिकल का एंगल है, दैट इज कॉल्ड स्कैटरिंग एंगल। Is this clear what I am saying?
नो सर,
सर
No. Why?
नो सर, आपने जो ये एसिम्प्टोटिक वाला पार्ट बताया ना, उससे एक
हाँ
बार फिर
देखो,
से बताइए।
इसीलिए एसिम्प्टोटिक लाइन लेते हैं। आपका जो अल्फा पार्टिकल आया है ना, एग्जैक्टली शार्पली तो स्ट्रेट लाइन जैसे नहीं जाता है ना, ये आपका इस तरह से जाता है, कर्व जैसे होता है इसमें। और कर्व से आपका एसिम्प्टोटिक लाइन कैसे बनाते हैं, मैथमेटिक्स में थोड़ा सीख लिया करो। एक आपका स्ट्रेट लाइन लेते हैं ना, कोई कर्व है यहाँ से, तो इसका एक डायरेक्शन आपको चाहिए ना। जो आपका अल्फा पार्टिकल आया है कैसे स्कैटर्ड हुआ है, काइंड ऑफ कर्व। So you have to draw a line corresponding to this curve. So if I draw that line corresponding to this curve, it will be like this, है ना। मैथमेटिक्स में थोड़ा सीख लिया करो कि जब आपका कोई कर्व जैसा होता है वहां से एसिम्प्टोटिक लाइन कैसे बनाते हैं, ठीक है। ये तो है, इस जो डिपार्टेड अल्फा पार्टिकल का जो ये है एसिम्प्टोटिक लाइन है, दैट विल बी लाइक दिस, एंड यू हैव ए इंसिडेंट अल्फा पार्टिकल का डायरेक्शन ये है। तो इनके बीच में जो एंगल है, दैट इज कॉल्ड स्कैटरिंग।
सर सर, तो ये जहाँ से स्कैटरिंग शुरू हो रहा है वो वाला एंगल, क्योंकि स्कैटरिंग तो बहुत सारे एंगल्स पे होंगे ना।
कौन सा?
जैसे जो जहाँ से स्कैटरिंग शुरू हो रहा है वो वाला एंगल की स्कैटरिंग, जैसे अब दूसरा
देखो उसीलिए आपका वो एसिम्प्टोटिक लाइन लेते हैं।
जैसे
हाँ, उसीलिए आपका एसिम्प्टोटिक लाइन लेते हैं। इट विल बी लाइक ए कर्व, यू नो, दैट्स व्हाट आई एम अगेन रिपीटिंग। सो जो स्कैटरिंग हो रहा है, इट विल बी लाइक ए कर्व। तो उसीलिए स्कैटरिंग एंगल को डिफाइन करने के लिए उस कर्व का कॉरस्पॉन्डिंग एक एसिम्प्टोटिक लाइन ड्रॉ करते हैं। तो वो जो लाइन है और जो इंसिडेंट अल्फा पार्टिकल का जो ये है डायरेक्शन है, उनके बीच में जो एंगल है, दैट इज कॉल्ड
scattering angle.
एंगल। So it is
So,
very
but
simple.
can there be different scattering angle?
Of course it can. Why not? Because you
Okay,
have,
sir.
हाँ,
Because
ये डिपेंड
different,
करेगा ना।
yes, sir.
तो आपका जो अल्फा पार्टिकल जो आपका सपोज मान लो बहुत करीब आ रहा है न्यूक्लियस का, उसमें तो आपका स्कैटरिंग एंगल ऑब्वियसली ज्यादा होंगे।
ज्यादा होगा।
हाँ, थोड़ा जो दूर पे होगा उसके लिए थोड़ा और कम होंगे। जो बहुत दूर में होगा, लाइक इलेक्ट्रॉनिक ऑर्बिट में वो जो होगा, है ना, उसके लिए कुछ नहीं
उसका
होंगे।
0 होगा। ओके सर।
ठीक है।
सर, आई हैव
यस।
वन मोर डाउट। सर, जैसे आपने कहा ना कि जैसे हमारा जो इंसिडेंट रे है, जो
हाँ,
मतलब फर्स्ट आपने ड्रॉ किया, वो इंसिडेंट हुआ, उसके बाद जो सेकंड इंसिडेंट रे है, वो जो एसिम्प्टोटिक गया, वो उसके बीच का एंगल आप बात कर रहे हैं ना।
देखिए ये जो आपका डायरेक्शन ऑफ इंसिडेंट अल्फा पार्टिकल है ना, ये आपका अल्फा पार्टिकल है, किधर जा रहा है, इधर है ना। ये बहुत
यस सर।
दूर है अभी न्यूक्लियस से। तो इंसिडेंट अल्फा पार्टिकल का जो डायरेक्शन है ये है। एक्चुअली इधर नहीं जा रहा है आपका अल्फा पार्टिकल, ये क्या है,
ओके।
ये आपका डायरेक्शन है, इंसिडेंट अल्फा पार्टिकल का डायरेक्शन है। उसीलिए आप पढ़ो जो मैंने क्या लिखा, इट इज डिफाइंड द एंगल बिटवीन डायरेक्शन ऑफ इंसिडेंट अल्फा पार्टिकल। जो इंसिडेंट अल्फा पार्टिकल का डायरेक्शन है, बट रियलिटी में क्या हो रहा है, स्कैटर्ड हो रहा है।
ओके सर, गॉट इट,
ठीक
गॉट
है
इट,
ना।
गॉट इट।
ओके।
सिर्फ सेकंड वाले केस में इम्पैक्ट पैरामीटर कौन सा होगा?
सेकंड वाला केस में मतलब
मतलब जो स्कैटर्ड हो गया तो उसमें इम्पैक्ट, वो तो इसमें भी फोर्स लग रहा है, तो हम एज्यूम कैसे करेंगे कि मतलब वो ऐसे कंसिडर करेंगे कि वो स्कैटर्ड नहीं हुआ फिर इंसिडेंट लाइन सीधा ड्रॉ कर देंगे?
अच्छा, जो कौन से इंसिडेंट वाला की बात कर रहे हो या डिपार्टेड वाला की बात कर रहे हो, बताओ।
सर मतलब उसी वाले केस में डिपार्ट हो गया तो फिर इम्पैक्ट पैरामीटर कौन सा लेंगे?
हाँ, वही मैं बता रहा हूँ ना, जैसे आपका काफी दूर पे जब है आपका अल्फा पार्टिकल, है ना, तो वो आपका इंसिडेंट अल्फा पार्टिकल है ना। तो वो इंसिडेंट अल्फा पार्टिकल, आप वो इंसिडेंट अल्फा पार्टिकल को आप डिफाइन कर लो इस तरह से कि आपका इंसिडेंट अल्फा पार्टिकल का डायरेक्शन है। ठीक है, ये आपका इंसिडेंट अल्फा पार्टिकल का डायरेक्शन है, बट क्या हो रहा है, जैसे जैसे करीब आ रहा है, इट विल बी डिपार्टेड और स्कैटर्ड लाइक दिस। ये आपका ओरिजिनल पाथ था, बट क्या है, आपका स्कैटर्ड होकर इस तरह से चला गया। है ना, ये आपका इंसिडेंट अल्फा पार्टिकल का डायरेक्शन है, और ये आपका क्या है, स्कैटर्ड है ना। अब यहां से मैं एक एसिम्प्टोटिक लाइन बना लूंगा, ये जो एंगल है दैट इज कॉल्ड स्कैटर्ड एंगल। यस, या मोर डाउट?
ये पहले
योर वॉइस इज नॉट क्लियर, कैन यू प्लीज रिपीट? आई कांट सी। I can't. I can't hear. Can you please type a message? Can
Sir,
you?
when it is scattered, the
I can't hear actually what you are saying. Can you please type a message? Yes, anyone? और कोई दूसरा रिपीट करो, मेरे को एक्चुअली सुनाई नहीं दे रहा है।
Sir, when it is scattered, what is the B value is asking?
When it is scattered, what is the?
B.
Oh,
B
okay,
value.
okay, okay. Now I'll actually going to discuss that. Now we are going to discuss. So actually, Rutherford also derived the relation between scattering angle and derived the relation between scattering angle, relation between B and theta. Okay, so before going to this, I'll derive that also, but I must say कि when it is scattered, what is the B value? तो जो smallest separation है, smallest distance between, smallest जो separation है, smallest distance between B, smallest distance between what? B and sorry, smallest distance between what I'm saying?
न्यूक्लियस एंड स्कैटर अनस्कैटर्ड।
सपोज मान लो ये आपका न्यूक्लियस है ना, सपोज मान लो ये आपका न्यूक्लियस है, और आपका ये आपका लाइन है अराउंड न्यूक्लियस, और जो आपका अल्फा पार्टिकल है इट इज इंसिडेंट लाइक दिस, है ना। तो ये जो डिस्टेंस है इसी को क्या बोलते हैं हम, इसी को क्या बोलते हैं हम?
इम्पैक्ट पैरामीटर
ये बोलते हैं। सो यू आर सेइंग व्हेन इट इज स्कैटरिंग, स्कैटरिंग के ऊपर डिपेंड नहीं है ये, क्या किसके ऊपर डिपेंड है कि जो पार्टिकल, सपोज मान लो अल्फा पार्टिकल आ रहा है, उसका पाथ अगर अनडेविएटेड हो, उसका पाथ अगर अनडेविएटेड हो तो किस तरह से चलेगा, इस तरह से चलेगा, सीधा चलेगा। तो वहां से ये जो डिस्टेंस है दैट इज कॉल्ड इम्पैक्ट पैरामीटर। सो व्हेन इट इज स्कैटर्ड नॉट, इट इज नॉट डिपेंडेंट, जस्ट आपको क्या लेना पड़ेगा, इफ द अल्फा पार्टिकल इज अनडेविएटेड इट विल गो स्ट्रेट लाइन, and distance from the nucleus to that alpha particle, that
सर
is
ये भी वैरी करेगा सर?
क्या वैरी करेगा?
सर ये
बी की वैल्यू।
Of course, you see, now I am going to discuss the relation between B and theta. Okay, so to derive that he assumed two things, please write that. जो first assumption था, he assumed two things. Assumption, जो first assumption था, the alpha particle and target nucleus, alpha particle and target nucleus both are point charge. The alpha particle and target nucleus both are actually point charge. So he assumed to derive this relation B and theta, he assumed that the alpha particle and target nucleus both are point charge. And second assumption, assumption number 2, the mass of target nucleus is very high. The mass of target nucleus is very high. Full stop. Therefore, after scattering, no shift in the position of target nucleus. Therefore, after scattering, there is no shift in the position of alpha particle. Okay. So basically, he derived that relation between impact parameter and scattering angle. And to derive that, he assumed two things. One thing is alpha particle and target nucleus. Both are point charge. And second, that the mass of alpha particle or target nucleus is very high. So after scattering, there is no shift in the position of target nucleus. Okay. And he derived this relation. I am not going to derive. Okay. Because this will not help you.
Sir,
Yes.
so the last line you
Third
said,
assumption, can you explain?
Second assumption na. So the mass
Third
of
one.
दो ही assumption है यहाँ पे. So first जो है alpha particle and target nucleus both are point charge. Second assumption जो है the mass of target nucleus is very high. Full stop. Therefore, after scattering, there is no shift in the position of target nucleus. So there is basically two assumptions. Okay.
Sir, no shift in position of alpha particle का क्या मतलब हुआ?
भाई दोनों के बीच में फोर्स कम कर रहे हैं ना.
Yes sir.
अल्फा पार्टिकल है, ये भी आपका अल्फा, ये सॉरी अल्फा पार्टिकल है, आपका टारगेट न्यूक्लियस है. दोनों के बीच में कूलम फोर्स कम कर रहे हैं नहीं.
Yes sir.
कूलम फोर्स के कारण ये भी तो शिफ्ट हो सकता है ना. बट शिफ्ट क्यों नहीं होगा? क्योंकि काफी भारी है, ये काफी वेट है ना इसका.
Oh, you are talking about the nucleus.
एग्जैक्टली टारगेट न्यूक्लियस आई एम सेइंग ना बार बार.
Okay sir. Okay sir.
Am I audible?
Yes, sir.
yes, sir.
Now based on these two assumption, he derived that relation between what? B and theta. I am not going to derive because this will not help you in your competitive exam. So just I'll write ZE square by 4 pi epsilon naught K alpha cot theta by 2. So impact parameter Z square by equals to, this is B. B is impact parameter, that is equals to Z square by 4 pi epsilon naught K alpha cot theta by 2. And what is Z here?
Atomic number.
Atomic number of target. Atomic number of target nucleus. Target nucleus. What is K alpha? You know that. Kinetic energy of incident alpha particle. Kinetic energy of incident alpha particle. And what is theta? Particle, right? What is theta? Theta is
Angle.
okay. Now you see. Now we can see many observations like so you tell me when theta, we can see that impact parameter is depend upon scattering angle. So tell me, if we increase the value of theta, what will happen? Or I can say in other words, if I increase the value of B, what will happen?
The scattering angle will decrease.
Theta will decrease.
Theta will be decreased. And this is very, you will get this thing from here itself. So B depends upon cot theta by 2. Now I am saying, अगर B ज्यादा है, है ना? तो बी ज्यादा कब है देखो आपका यहाँ पे क्या है cot थीटा बाई 2 and that is nothing but cosine theta by 2 by sin theta by 2, right? Cosine theta by 2 by sin theta by 2, that I can write. So B depends upon cosine theta by 2 by sin theta by 2. Now if B is large, B large कब possible है? जब आपका ये वाला फैक्टर ज्यादा है, और ए वाला फैक्टर कब ज्यादा होगा? जब थीटा स्मॉल होगा, क्योंकि
cos 0 पे
हाँ दैट्स व्हाट आई एम सेइंग, अगर B ज्यादा है, B ज्यादा कब पॉसिबल है? जब आपका थीटा स्मॉल, बिकॉज वी नो दैट स्मॉल थीटा पे cot थीटा का वैल्यू ज्यादा होता है, बिकॉज cot थीटा इज नथिंग बट कोसाइन थीटा बाई साइन थीटा, है ना? तो स्मॉल थीटा पे कोसाइन थीटा ज्यादा होता है और आपका नीचे साइन थीटा है वो कम होता है, तो ऑन बाई नीचे कुछ कम मतलब ज्यादा है। तो मेरा कहने का पर्पज यही है कि अगर बी ज्यादा आप इंक्रीज करते जाओगे, एक्चुअली आपका थीटा क्या होगा? डिक्रीज होता जाएगा। इस इक्वेशन से आप बोल सकते हो। नहीं, और इन अदर और ये भी बोल सकते हो, अगर आप सपोज मान लो आप थीटा इंक्रीज कर रहे हो तो एक्चुअली क्या होगा आपका? और इफ यू डिक्रीज दैट द वैल्यू ऑफ थीटा, व्हाट विल हैपन? एक्चुअली बी विल बी इंक्रीजिंग। क्या हम बोल सकते हैं ये? सब लोग बताओ।
Yes, sir.
I can say, right,
Yes,
from
sir.
this equation, if you
Yes, sir.
increase the, if you decrease the value of theta, b will be increasing. Or if you increase that value of theta, if you decrease the value of theta, b will be increasing. And if you increase that value of theta, b will be what? It will be decreasing. And tell me, if b is much greater than r, r क्या है यहाँ पे? Radius of nucleus. Then what will happen?
Theta is equal to 0 degree.
Exactly, theta will be 0. Now if b less than r, tell me what will happen?
Theta is equal to 180 degree.
Exactly. On 80 degree. This thing actually obvious, right? That if you increase that value or decrease the value of theta, b will be increasing. Right? Why? Because you have a, suppose you have a nucleus. Let me explain that, then I'll stop here. So suppose you have a nucleus. You have a nucleus and theta decreasing. Theta decreasing कब है? जब आपका काफी दूर से जाएगा आपका, है ना? ये आपका सपोज मान लो पूरा एटॉम है, तो काफी दूर से जब जाएगा उस टाइम क्या होगा? जो थीटा होगा इट विल बी स्मॉल, राइट? व्हाट आई एम सेइंग,
कम स्कैटर्ड करेगा।
हाँ, थीटा स्मॉल कब होगा? जब आपका काफी दूर पे रहेगा, that incident particle is far away from nucleus, then theta will be small, right? Theta will be small. And at this situation you can see, when this target this alpha particle is far away from nucleus, then b is actually high. At this situation that scattering angle will be small. अगर बहुत पास में आ गया, है ना, तो आपका क्या है? बेसिकली बहुत पास में आ गया मतलब b स्मॉल हो गया। इस सिचुएशन में क्या होगा? ड्यू टू हाई कूलम्ब फोर्स, स्कैटरिंग विल बी लार्ज।
स्कैटरिंग ज्यादा होगा।
अब जब आपका ये आपका रेडियस, न्यूक्लियस का रेडियस r है, r से स्मॉल में जाएगा, तब क्या होगा? बैक स्कैटर्ड हो जाएगा, ठीक है ना? और जब बहुत दूर है, जब आपका बहुत दूर है, तो फिर क्या होगा? कोई स्कैटरिंग ही नहीं होगा, थीटा इक्वल टू 0 हो जाएगा। So whatever formula he has derived based on two assumptions, that is exactly fitting with the experimental result. Okay. So this is the Rutherford discussion, but one thing I have to discuss, that is distance of closest approach. Tomorrow I'll discuss that part. Okay.
Okay, sir.
Okay. Yes. You have question?
सर आपने जो ये थर्ड वाला बताया ना बैक स्कैटरिंग, एक बार फिर से एक्सप्लेन कर दीजिए।
बैक स्कैटरिंग ना, तो अब देखो, जब आपका इम्पैक्ट पैरामीटर बी से आर से स्मॉल है, आर से स्मॉल मतलब ये आपका R है, इस R से स्मॉल है, तो अल्फा पार्टिकल एक्चुअली का किस रीजन में आ रहा है?
न्यूक्लियस के रीजन में।
हाँ, न्यूक्लियस के रीजन में। तो न्यूक्लियस के रीजन में जब आएंगे तो क्या हो जाएगा, वो बैक स्कैटर्ड ही होगा ना।
यस सर।
ठीक है। So this is all about that Rutherford scattering discussion. One more thing I have to discuss, that is distance of closest approach. Tomorrow I'll take 5 or 10 minutes, then I'll proceed further. Okay, I should stop it.
थैंक यू सर।
Thank you.